Okay, in this video I want to illustrate the different conformations of ethane and also how you can represent those different conformations using a type of drawing called a Newman projection. So here I have a molecular model of ethane. Got two carbons, it's very saturated with hydrogens, and what we're going to focus on in these conformations of ethane is this carbon-carbon bond. This is a sigma bond and it has free rotation. And so we can imagine there's lots of different possible three-dimensional arrangements of these atoms in space, and these different arrangements or conformations may have different stabilities and energies associated with them. Okay, the most helpful way to look at this model if we're trying to visualize these different conformations is to line up our line of sight with the carbon-carbon bond. Okay, so we're going to look down the carbon 1 carbon 2 bond and try to line it up with our sight, and then if we rotate that sigma bond we can see how the hydrogen substituents on each of the carbons are arranged in three-dimensional space relative to each other. Okay, so before I talk about the different stabilities of these different conformations, it'd be nice to be able to draw these different conformations of ethane on a piece of paper without having to have a model. And so we're going to use something called a Newman projection. I'll put the model down here. And what I'm going to do is draw a Newman projection which is focused. Newman projections are always focused on one carbon-carbon bond. Okay, so here's the easiest way to think about it. Is the carbon closest to you, I'm going to illustrate with just a little dot. And the carbon furthest from you, down that carbon-carbon bond, we're going to have as a big circle. Okay, so in this particular instance, if I'm looking at ethane, the near carbon here is this dot. The far carbon further away from me is this big circle. We just made it a big circle so we can see it behind the first carbon. Now each of these carbons are bound to each other, and that takes up one of their bonds, but they're bound to three other things. And so for each carbon I'm going to draw three bonds representing the three other substituents attached to them, and in this case they're hydrogens. So carbon 1 is bound to carbon 2, and it's bound to three other hydrogens. Carbon 2 in the back is bound to carbon 1, and it's bound to three other things. And it's really where I put these other three bonds which illustrates the particular conformation we're looking at. So let's look at this model here. Okay, what I've got is what we call a staggered conformation, where each of the hydrogens are staggered from each other, as far away from each other as possible, 30 degrees from each other. And so what I can do is represent the staggered conformation on my Newman projection by putting the three other bonds from carbon 2 in staggered positions. Now in ethane, that second carbon, all of these three positions are also filled up with hydrogens. So this is a Newman projection which illustrates the particular conformation of ethane that's represented by this model, and we can name it staggered. And this is the most stable conformation of ethane. You can imagine drawing other Newman projections which represent other conformations. Let's rotate that carbon-carbon bond to get sort of the opposite, where these hydrogens are lined up with each other. Okay, we call this an eclipsed conformation, and you can see why. Let's imagine this hydrogen on carbon 2 is the sun. This hydrogen that's closer to you is the moon. And when we move to a conformation where the hydrogens line up, the moon is eclipsing the sun. We've got a solar eclipse. Okay, and you might imagine this is a relatively unstable conformation of ethane because there's potential for steric hindrance with these hydrogens which are lined up. Okay, so how do I draw this eclipse conformation as a Newman projection? Well, do it the same way basically. Here's my near carbon. Here's my far carbon, carbon number 2. My near carbon has three other substituents attached to it. They are still hydrogen because we're dealing with ethane. And here's where my Newman projection is going to change from the staggered. In the carbon number 2, the back carbon, also has 3 hydrogens attached to it, but I'm going to draw their bonds as close to eclipsing these near hydrogens as possible, so that we can really see these hydrogens are bumping into each other. It's actually hard to draw this Newman projection. It's not a very stable Newman projection, and so this is how you would draw the eclipsed conformation. Now you might imagine there's really an infinite number of possibilities for conformations of ethane depending on what angle you have on this carbon-carbon bond, and each of these have different stabilities, but we typically think of staggered and eclipsed as the two extremes, the most stable, the least stable.